Hello. Today we are going to be performing an electrical safety test on this device. We will be using this SA2010 safety analyzer to perform the test. The first thing we are going to do is plug the safety analyzer into the wall. Now that the analyzer is plugged in, we can see that it is on because of the LEDs that have come on. When the device powers up, the display shows the voltage and the units displayed are in volts. There are two LEDs on the left side of the display that show the condition of the line itself. They show whether the polarity and the ground are okay. It is critical that we make sure this is correct before we go any farther, because if there's a problem here, then the rest of our test isn't going to give us true results. There's a table of the different LED possibilities and their meanings on the back of the analyzer itself. Next, we are going to connect our device under test to the safety analyzer. We will plug one end of the power cord to the device under test and plug the other end into the test receptacle of the safety analyzer. I would like to remind you that the test receptacle is not just a pass-through. It is controlled by the safety analyzer. You will notice that although we have the device under test plugged in, we are not getting any power to that device. The reason for that is when the analyzer powers up, for safety, it puts the hot wire on the test receptacle into an open state, and no power is going to the device under test. If we close the hot wire, we will notice now that the device under test will start to power up. The first test that we will perform is the ground wire resistance test. In order to do this, we will need to have a Kelvin cable connected to the chassis input on the analyzer and connect the other end to the ground lug on the device under test. Now that our setup is correct, we will set the mode of our safety analyzer to earth resistance. This is done by pushing the down arrow 2 times. The LED will now indicate earth resistance and the units will be listed in ohms. Our device under test is currently showing 0.04 ohms. In order for this device to pass, the value needs to be 0.5 ohms or less. Therefore, this test is a pass. The next test we will perform is the current leakage test. There's a couple of ways to do this. The first way I will demonstrate is by setting the mode to earth ground. Notice by default, the test receptacle is showing that the ground wire is open. Internally, the leakage current is measured through the safety ground line from the device. This is the current that would normally be flowing through the ground wire. The Kelvin lead is not necessary for this test. The number we are seeing on the display is in microamps. This value is 85 microamps. The tolerable spec for this device is 300 microamps or less. Therefore, our device is passing. Another way that we can do a leakage test is to change the mode of the analyzer to enclosure. Notice how all three inputs, ground, hot, and neutral, are all closed. Also notice that the value on the display is 0. This is because all of the leakage current is flowing through the ground wire on the test receptacle. In order to measure the leakage current, we need to open up the ground wire so that the leakage current will flow through the Kelvin lead and be measured. When we press and hold the open button, we notice that our leakage current is again at the same value we measured before. This is all that is required for testing a device that has no patient leads. For a defibrillator or an ECG machine, we are going to use the leads, and there's another set of tests that we will perform to do a leakage test on those. But for this device, we are complete.